Now we are solving maximization problem in assignment. Here we have an example. In this example, cost matrix is given. In that matrix, we have 4 salesperson, that is A, B, C and D, and 4 areas W, X, Y and Z are given. We have to find the optimal assignment schedule and the total maximum sale. See here, we have a total maximum sale is given. So this type of problem is maximum assignment problem. First, we have to convert this maximum assignment problem into minimization problem, and then we have to find optimal assignment solution. So for that, we have to follow these steps. First one, convert maximization problem into minimization problem by subtracting all the elements from the largest value. See, in this matrix, first we have to consider the largest number. So in this matrix, largest number is 60. So we have to subtract all the elements from the largest value, that is 60. Next, step 2, row reduction method. Step 3, column reduction, and step 4, assigning and finding optimal solution. These 3 steps which we already used in minimization case. Okay. Before proceeding the problem, we first check whether it is balanced or unbalanced. In this problem, we have 4 rows and 4 columns. So both are equal, therefore it is balanced assignment. Now we have to convert maximization into minimization problem. So first, step 1, consider the largest number, that is 60. Now we have to subtract all the elements. So first value, salesman A, area W, that value is 50. So largest element is 60. So 60 minus 50, 10, 60 minus 40, 20, 60 minus 60, 0, 45. If you subtract, you will get 15. Next, 60 minus 35, 60 minus 45, 60 minus 50, next 60 minus 40, 20, 60 minus 50, that is 10, this is 0, and 25, and 45, that is 60 minus 45 is 15, this is again 15, this is 10, 60. Now we have to move on to step 2, that is row reduction. Row reduction means we have to select minimum value in each row and subtract the rest of the elements from that row. So first consider minimum value in first row. First row minimum 10, 20, 0, 15. So 0 is the minimum. If you subtract all the values, you get the same. So that is 10, 20, 0, 15. In the second row, minimum is 10. If you subtract, you will get 25 minus 10, 15, 15 minus 10, 5. This is 0, this is 10. The third and fourth row, we have 0. So if you subtract, you will get the same values again. So just write the values as it is: 20, 10, 0, 25, and this is 15, 15, 10, 0. After this row reduction, we have to move on to the column reduction. Column reduction means we have to select minimum value in each column and subtract it from the elements of that column. Okay. So first consider first column. In that first column, minimum is 10. If you subtract, you will get 10 minus 10, 0. Next, 15 minus 10, 5, 20 minus 10, and 15 minus 10. In that second column, minimum is 5. So 20 minus 5, 15, 5 minus 5, 10 minus 5, that is 5, 15 minus 5. In the third and fourth column we have 0. So if you subtract, you will get the same values. So 0, 0, 0, 10, 15, 10, 25, 0. After this column reduction step, now we have to assign and finding the optimal solution. So first we assign the zeros. So first consider first row. In that first row we have 2 zeros. So we usually assign the row which we have only 1 0. So in that row we have 2 zeros. So I move on to the second row. Second row also we have 2 zeros. So we skip that row and we move on to the third row. In the third row I have only 1 0. So first I am going to assign the 0. If I assign the 0, that corresponding column will get cancelled. Okay. Next move on to the last row. In the last row I have only 1 0. So I am assigning this. If I assign the 0, that corresponding column will get cancelled. So now we have to move on to the column wise checking. So first consider first column. In that first column I have only 1 0. So I am going to assign this. If I assign this, corresponding row will get cancelled. Next move on to second column. In that second column I have only 1 0. So I am assigning this. If I assign this, corresponding row will get cancelled. Next move on to third column. Already we have assigned the 0. And move on to last column. Here also already we have an assignment. So after this you have to check whether all the rows have an assignment. See, in the first row we have an assignment, and in the second row also we have an assignment. Similarly we have third and fourth row also have assignment. See, we have 4 lines and we have 4 assignments. So both are equal. So we reach the optimal solution. So first write optimal solution, that is optimal schedule is, we are assigning salesman A to area W and salesman B, here we have an assignment, right? So that is salesman B area X. For salesman C, here we have an assignment that corresponds to Y area. So area Y, and salesman D is it area. We have to find the values from the main matrix. So salesman A to W, B to X, C to Y, and D to Z. So the values are, so from the main matrix, A to W, that is 50, B to X 45, C to Y 60, and D to Z 60. See these 4 values, right? 50, 45, 60 and 60. Now we have to add all the values. That is 50, 45, 60 and 60. The total is 215. So this is the assignment cost value. Thank you.